Hello everyone, I'm going to show you how to do a two-sample z-test for a difference in proportions. Alright, so here's the situation. Researchers want to test the effectiveness of a new anti-anxiety medication, and in clinical testing, 64 out of 200 people taking the medication report symptoms of anxiety. Of the people receiving a placebo, 92 out of 200 report symptoms of anxiety. Is the medication working any differently than the placebo? And we want to test this claim using an alpha of 0.05. Okay, so we're testing a claim, which means we are going to do a hypothesis test. So we're going to start off with P, our parameters. We have two different samples. So we have P hat for the first sample, which was 64 out of 200, which is 0.32. And then we have P hat for the second sample, which was 92 out of 200, which is 0.46. And since this is a two sample, we also need to have a p hat of the cumulative, of the total, which would be, if we add those two together, if I do my math right, 156 out of 400, which, go over to the calculator, make sure I'm doing that right, 64.92, that works, 156 divided by 400, it's going to be 0.39, and let me just make sure, 64 plus 92, sure enough, is 156. So my p-value then is going to be 0.39 for that one. Now we also need to say what each thing is. So p hat 1 is sample proportion of people taking medication, people taking the meds. And then p hat 2 is proportion placebo. And these are people who report anxiety. So you could say reporting anxiety. You always want to be very clear about what you're talking about. And then p hat c, total of both samples reporting anxiety symptoms. Alright, so that's what we're given. So then we can do our hypothesis. So our hypothesis is that there is a difference, or that there is no difference. So we would want to state that the hypothesis is that P1 minus P2 equals 0. Or you might say P1 equals P2. And then the alternate, so that's your null, and then your alternate would be that P1 minus P2 does not equal 0. And you want to make sure you say P1 equals true proportion of people taking meds and reporting anxiety. And P2 is true proportion of people taking a placebo and reporting anxiety symptoms. Alright, so then next up is our assumptions. So our assumptions are slightly different for a 2 sample than they are for the other ones. So first we need to test, are they random? So we could say data was collected via a randomized controlled experiment. Okay, so since it was done with an experiment, that means we don't have to worry about simple random sample. That's where our data comes from. Secondly, we need to test and see whether we can use a normal approximation. So to use a normal approximation, we need to test both N1, P1, and N1 times P1 minus P1. Alright, so N1 would be 200. Sorry, I should put hats there. So 200 times 0.32, which is 64. And this is going to be 200 times 68, which is going to be 136. And then N2 P hat 2 is going to be 200 times 46, which equals 92. And N2 times 1 minus P hat 2 is going to equal 200 times 0.54, which is going to equal 108. So since all are greater than 10, we can assume normality. And then finally, since they're independent, we would need to talk about the 10% rule, which would basically say we check the 10% condition. So we'd have to say we must assume I want to phrase this. Go up to the top, 200 people. We must assume more than 10 times 200 people to draw volunteers from. Okay, so those are our 3 assumptions. Next up, we're going to name it. So this is a 2 sample z-test for differences in proportions. Okay, and then the formula for this is z equals p hat 1 minus p hat 2 minus 0, because up here we said p1 minus p2, right up here we said p1 minus p2 equals 0, so that's why we could put a 0 in there, divided by the square root of p hat c times 1 minus p hat c over n1 plus p hat c times 1 minus p hat c over n2 equals. So let's put our numbers in. So p hat 1 was 0.32 minus p hat 2 was 0.46 over p hat c, I believe if I remember correctly, was 0.39. Let's make sure. If I go up, yep, p hat c was 0.39, so it'd be 0.39 times 0.51, 61, right the first time, over 200 plus 0.39 times 0.61 over 200 equals. So now I'm going to go over to the calculator and let the calculator do some of this work for me. So if I go over to stats, tests, I want to do a 2 proportion z test. So number 6. We need to put in our numbers. Alright, so let me go back up to the top. For the first one, it was 64 out of 200. So 64 out of 200. And then for the next one, it was 92 out of 200. And we are saying that they are not equal, so we can leave that the way it is. And then we can draw our picture. And so then you can see that our z star value, our c value becomes negative 2.87. Okay, which would be our p-value of 0.0041. And our conclusion is we reject. And we can make our statement. Our statement would be that since p is less than 5%, we reject the null. There is strong evidence. I mean, it's a very low p-value, so we can say strong evidence to conclude the proportion of people reporting anxiety symptoms is different for groups taking medication versus a placebo. Alright, so since p is less than 5%, we reject the null. There is strong evidence to conclude the proportions of people reporting anxiety symptoms is different for groups taking meds versus a placebo. And then don't forget to put your picture in there. And so here's my picture, so I can put that in there as well. And that's it. That's all you do. So hopefully that helps clarify a few things, and I will see you in class next time.